Let's look at this example. We are asked to find theta in terms of t and it satisfies this dE. Okay, so this is just a different way of asking you to solve for the general solution of this dE. Okay, now so let's examine this dE. Again, you notice that it seems that there's only a function of theta inside here. There is no function of t. But just like the previous example, you can just pretend the constant, in this case k, to be the function of t. There's nothing wrong. Okay, so in this case, our dE still satisfy a separable equation. Okay, meaning that it's still in your syllabus and you should know how to solve it. Okay, so we're going to use the same problem solving process, which is to put all the terms with theta, including the d theta, on one side, and in this case our constant and dt on the other side. Okay, and then we're just going to integrate both sides of this equation, which leads us to this step. Okay, so a simple integration would give us this result. Unfortunately, we cannot stop here because the question asks you to find theta in terms of t, means that we need to go ahead and make theta the subject. Alright, so we'll change the form from a logarithmic form to a index form. Okay, but again, we cannot just stop here because we need to drop the modulus. If not, it is not considered simplified. Okay, and the next few steps are very, very important, so make sure you write down any notes that you have to. Now, so in order to drop the modulus, first let me split this term up, e to the power of kt plus c, into e power c multiplied by e power kt. Okay, this is by law, the law of indices. Okay, that you can do this. And next step, I'm going to replace my e power c with this arbitrary constant a, and that there's nothing wrong with such replacement because a is just simply the constant e power c. Okay, and the next step, I'm going to drop my modulus. And how do I go about dropping my modulus? I'm going to replace my a with another arbitrary constant called b. Okay, and what does this b actually means? How does it relate to a? So b in this case can take the value a if this thing in the modulus, which is my theta, is more than or equals to 0. Okay, so meaning that if your theta is more than 0, you just drop the mod, right? Nothing will happen. Okay, so a will just remains as a. Okay, meaning that b is going to be a. Now, but in the event that the theta is actually negative, okay, to drop your modulus, you remember you have to multiply a negative, right? So in this case, your b will take the value negative a. Okay, so this is the step-by-step presentation of how you should drop your modulus to eventually arrive at the solution to the dE in the form theta in terms of t. Okay, now so in the presentation, what is necessary? Okay, you need to of course have a very good understanding of what is this a and what does this b means, okay, as you're trying to drop the modulus. But there is no need to write down how your e to the power c changed to a, and then how your a changed to b, and what does b means, what does a means. Okay, unless of course the question wants you to elaborate. Okay, if not, there's really no need to write all this.